Alright guys, so we're getting into like the super fun stuff, the stuff that I super love. We're going to be using sine and cosine to describe points, and we'll also be doing a little bit of a review over tangent. So we're going to start with reference angles because we need this to accomplish a lot of what we're going to be doing today. So if theta is an angle in standard position, its reference angle, or R, is an acute angle formed by the terminal side in the x-axis. So what that means is if this is my angle right here, then its reference angle is exactly the same. However, if it's over here, the reference angle is this angle right here. This makes it a lot easier. Notice that then we have a triangle that we can use if we wanted to, which we do, and all sorts of stuff. Okay. So it all depends on which quadrant it is in to see what that reference angle will be. Notice that it's always going to be this cute little triangle that we can create. Notice that we have a cute little bow tie. Remember, your triangle should be part of a bow tie. It's always going to come out from the center and then either down or out from the center and up to the x-axis. Okay, notice that it never has to do with the y-axis. We're always talking about the x-axis. All right, so if I was to do the reference angle for negative 230 degrees, I would first off figure out negative 230 means I'm rotating this way. And it'd be 30 degrees short of 360. So I'm starting here and I'm rotating 230 degrees to right there. So then my reference angle would be this angle right here, which is 30 degrees. Notice that we have a cute little triangle there. Okay, if I wanted negative 25 pi 18ths, then I would still rotate this way. Okay, and we're going to split pi into 18 pieces. So if I split it in half, that would be 9. If I split it into thirds, each piece would be 3. So right here would be 18 pi 18ths, 19 pi 18ths, 20 pi 18ths, 21 pi 18ths. Wait, I lied. They're going by threes. So this would be 18. This would be 21, 24, 27. So we want between 24 and 27. So we're going to split this into 3 more pieces. And then we find that our angle would be rotating from here to here. So it's this line here. So it'll be this angle, which makes our reference angle, let me do a different color, would be this angle right here. So that's going to be, let's see, that's 3, 6, 7 pi 18ths. Because there would be 3 portions right there, 3 portions right there, and then we want 1 extra portion there. So 7. So 3, 6, 7. Okay. Then if I want 31 pi 9ths, then I'm going to split from pi. And remember, if I'm rotating this way, first off, if I have 31 pi 9ths, that means that I'm going to rotate. So 18 pi 9ths would be a full rotation, right? So then we would want 1 full rotation. I drew that circle the wrong way. We want 1 full rotation. No, I had it the right way. I'm going insane. I want to rotate that way. So I want 1 full rotation plus more. So let's see. 32 pi 9ths would be 2 full rotations. So we're going to be just 1/9 short of another full rotation. So we'll be about there, right? Because if we split up between pi and 0 into 9 pieces, then we would do, let's see, split it up into thirds. So 1/3, 2/3, 3/3. And then we'd split each third up into thirds. There we go. Right there, right there. So then our angle is going to be from here, rotated all the way to here. which means our reference angle is just this, which is pi ninths. It's 1 pi ninths. Okay, again, if we have 640, we're going to take 640 minus 360. Oh, we have 280. So that means we're going to rotate, this is clockwise. So we're going to rotate a full 360 plus 240, which will be about, full 360. That's 270. And that's 180. So we'll be about there-ish, right? It'll be 30 degrees short of the angle over there. We'll be about there. Which means that my angle would be from here to here. And then my reference angle would be this angle right here, which is 60 degrees. All right, because it'd be 240 minus 180. (240 minus 180). That's 60. See, 60 degrees. All right. If you have any questions on this, please rewatch it and then try it again. Okay. So we're now going to go into finding the sine, cosine, and tangent of points. All right. So right here, your goal is to graph the point on the coordinate plane, draw a line connecting the point to the origin, draw another line perpendicular to the x-axis. So like if this was my point, so that was step 1. Then step 2, we draw this line. Step 3, we draw this line. And we're going to label this as theta. Okay. Then we'll label the lengths of the triangle legs. So like here's A, here's B, here's C. We'd use Pythagorean theorem to find the point lengths. So like we'd know A, we'd know B from the point. We could find C using Pythagorean theorem. And then from that, we're going to find sine of theta, cosine of theta, and tangent of theta, which you do not need theta to find those things. You just know that theta will give you those things. So let's practice this one right here. We're going to practice this one together. So I'm going to go over 4, 1, 2, 3, 4, down 3, 1, 2, 3. So here's my point. So now I'm going to draw my line to my center. So there's my line. And my line to my side. So I know how long most of these are actually already. I know this is 3 long, and I know this is 4 long. And if you remember Pythagorean theorem, hopefully you do, we've used it a lot this year, we would do 3 squared plus 4 squared equals c squared. And this ends up being 25 equals c squared. So you end up getting this length is 5. Okay? All right, so then sine, and then this is theta right here. In case you forgot to label that part. Okay, so then sine, you've got to remember this. We've got to remember so, ka, toa. So sine is going to be opposite over hypotenuse. So this would be 3 over 5. Cool, that's my sine. Then my cosine says adjacent over hypotenuse. So that would be 4 over 5. And then tangent would be opposite over adjacent, which is 3 over 4. There's my sine. Cosine is sine. Sine, cosine, and tangent of 4, negative 3. All right. If you need more time on that, rewind, pause, copy it down. Okay, I want you guys to go ahead and try this one. All right, now hopefully you paused the video and did it. If not, that's okay. I'm going to do it now anyway. So negative 2, negative 5 is going to be this point right here. So now if I connect it to my center, now I need to create this triangle with the origin and the x-axis. So this is 2 long. This is 5 long. So we would do 2 squared plus 5 squared equals c squared. So this would be 4 plus 25. So this is 29 equals c squared. So then c equals square root of 29. Perfect. All right. So then this is the square root of 29. Remember that this is theta right here, that angle right there. So then sine would then be opposite, which happens to be 5, over hypotenuse, which happens to be square root of 29. And I'm not going to make you rationalize the denominator right now. Just leave it as 5 over square root 29. Okay? And then cosine would be adjacent over hypotenuse, which is 2 over the square root of 29. All right, and then tangent is just going to be 5 over 2. Now, if I did want to rationalize the denominator, I would multiply the top and bottom by square root 29, and I would get to square root 29 over 29. These numbers are equivalent. It's just one is written without a square root in the bottom. Those numbers are exactly equal. Okay, do you have any questions here? If you do, please leave it in the comments below. And then this is the notes for today. If you need more practice, make up your own problems. You got this.